Hello, this is lesson 2, and today we're going to look at function notation and substitution, and also we're going to look at some piecewise functions and their graphs and substitution with those. This lesson is also considered a review lesson. Okay, so you probably are familiar with this, what I call the old way, where we have something like y equals 3x squared plus 2x, and you are to find y when x equals 5. So to do that, we substitute or plug 5 in for x. We have y equals 3 times 5 squared, and only what we're substituting in goes in the parentheses. So the square is on the outside of the 5. That means only the 5 is squared, plus 2, and we also have to plug in or substitute that 5 the second time we see x. Every time we see x, we replace it with 5. Then we use order of operation to simplify, so we do our exponent first. 5 squared is 25. 25 times 3 is 75. And of course we do addition last, so we have to then multiply the other side. 2 times 5 is 10. So just a reminder, please excuse my dear Aunt Sally, parentheses first. Well, there's no operation inside the parentheses. Then exponent, so we did our exponent, that would be 25, 5 squared is 25. Then we do a multiplication and division, so 25 times 3 and 10 times 5, there is no division. And then the last thing we do is addition, and so y equals 85. Now, that is not the way we do things very often in college algebra. We're going to look at this new way using function notation. So let's compare these two setups. F of x equals 3x squared plus 2x. If you look at these two, the only difference is that y has been replaced with f of x. And then it says find f of 5. So instead of f of x, we have f of 5, and that tells you that x has been replaced with 5. This is the function in terms of x, and it's telling you, this notation is telling you that x is your input variable. And down here it's saying replace that input variable with 5. So we have 3 times 5 squared, and again only the 5, that what you are substituting in should always go in parentheses. And then of course we would get the same answer because we have the same exact setup here as before, so that still equals 85. So that is function notation. Now instead of f of x, I could have g of x. I could name my function g, the g function, or the h of x, or any variable or any letter. Actually, this is not a variable, this f, it stands for function, but I could name it anything. One very common one is pH. So they actually use P, and then since H is talking about hydrogen positive ions, they put H positive. And that tells chemists this is the pH function. So it's like we're naming the function. But what's inside these parentheses is my input variable, or my independent variable. Okay, let's look at some more examples of function notation. Alright, function notation with substitution. So here I'm naming the function g of x instead of f of x, but still my input variable is still x, as you can see on this side. And I have two questions here. First, find g of -1, and then find g of b plus 3. So whatever is here in this parenthesis is what I'm replacing the input variable with. So in this case, it's -1. So every time I see x, I am replacing it with -1. So in this case, g of -1 equals, and now we're going to still put this parenthesis that was there, but we have to put the -1 inside of parentheses. So it's -1 minus 4. Now, had I not put these parentheses here, I would really have the same problem. But because you don't always know when the when they're necessary and when they're not, it's good to just always put them when you're around the term or number that you're substituting in. And now again, we're going to follow order of operations, do what's inside of these parentheses. So -1 minus 4 is -5. And I'm going to keep that outside parenthesis to remind me that this is a multiplication. I'm multiplying these two binomials together. -1 plus 5 is 4. And so a negative times a positive is a negative, and 5 times 4 is 20. So my answer is -20. So g of -1 equals -20. Alright, let's do the second part of this. I'd asked for g of b plus 3. Notice the b plus 3 is to replace every x value. So it goes in here, and it goes in here, and again, we first put it in parentheses. So g of b plus 3 equals, so I'm going to put the b plus 3 in its own parenthesis. So I do what's in parentheses first, and notice these inner parentheses here have unlike terms that are to be added. And of course we know we cannot add unlike terms. But we also know, according to our addition rules, that we can add these numbers. We've got, let's look on this side too, it'd be a little bit more clear. B plus 3 plus 5. We are allowed to add these in any way we want. This is called the associative property of addition. So since we can't add b to anything, we're going to add 3 plus 5 first. So we can have b plus 8 on this side. Now it's the same idea with subtraction, because minusing a positive number is the same as adding a negative number. So this is technically still the associative property of addition. So 3 plus -4 is -1. So this gives us b minus 1. Okay, so we have b minus 1 times b plus 8. So we, again, inside the parentheses, we cannot combine those because they're not like terms. But we can invoke what is called the distributive property, what we reviewed yesterday. So we do, this is two binomials, so we can use FOIL. So we're going to do b times b, which is b squared. It's our first terms. And then we're going to do b times 8, which is 8b, and those are both positive, so they make a positive when multiplied. And then we're going to do our inside terms, negative 1 times b, which is negative 1b or minus 1b, and we don't need the 1 because 1 times b is just b. And then last we have a negative 1 and an 8 multiplied together, which is minus 8. So now we combine our middle terms, which are our like terms. 8b minus b is 7b. So we have b squared plus 7b minus 8. And that may seem weird, but that is what g of b plus 3 equals. That is as far as we can go with that. Now everything we're learning on this review, I specifically kind of chose topics that I know are going to come out later. So later we're going to take this even a couple more steps, a couple more directions. So this idea of substitution and then simplifying what you get, that comes up later, and then there's also double substitutions and so on and so forth. Let's do another one of these just to make sure we got it. We've got h of a. I want to use here, I'm using not only another naming for my function, this is the function of h, but I'm using a different input variable. I'm using a equals a squared minus 5a. And I am to find h of negative 3 first. So that means I am replacing a with negative 3 every time I see it. And I specifically picked a negative number so that I could show you and remind you how to do this. I'm going to go ahead and type this. So h of negative 3 equals, and I'm going to keep that negative 3 in parentheses and insert it in every time I see the a, and then minus 5 times negative 3. And so we follow order of operations. H of negative 3 equals now negative 3 squared. So that means, following order of operation, we're looking at what's in the parentheses and we're multiplying it by itself. That means negative 3 times negative 3, which is a positive 9. Minus, and so that's treated as a negative 5. Let me not put the minus there yet. Minus 5 and minus 3 is a positive 15, so that becomes plus 15. And then we can finish it off by saying that's 24. And 24 is our answer. Okay, now let's do the next one. Next we have h of a plus 5. So we got to insert a plus 5 everywhere we have a, which is kind of weird because we're taking a out and putting a plus 5. So we have the same variable in what we're inputting, but we still do it the same way. And we have h of a plus 5, and that equals a plus 5 in parentheses, then on the outside of the parentheses it is squared, minus 5 times a plus 5. And so now we're going to simplify it, and we've got a couple things going on here. We have two sets of distributive properties. So this one right here, again, we cannot actually add a plus 5 because they're not like terms. So we are going to do the distributive property. A plus 5, so we have h of a plus 5 equals, and so for this one, this is the same as saying a plus 5 times a plus 5. And the second one I'm going to go ahead and distribute first. So it's minus 5a. Now that's a negative 5 times a positive 5. That makes a negative 25 or a minus 25. And now let's go ahead and do the a plus 5 times a plus 5. So that gives us a squared plus 5a plus 5a plus 25, and then we still have the minus 5a and the minus 25 from before, and now we can combine all of our like terms. We don't have another squared term, so we're going to have the a squared. We have 5a plus 5a, and then over here we have minus 5a. So these are like terms, and that is total 5a. And then we have plus 25 and minus 25, so they cancel, and so we're done. So the end of this problem, this is our answer, even though it's not a number once again. Our answer is h of a plus 5 equals a squared plus 5a. Alright, okay, now I'm going to do another one of these problems, but it is slightly different. H of a equals a squared minus 5. Find a when h of a equals 45. Notice I do not have a value placed for the input or the a value. Instead, I have a value given for the output, or the h of a value. So I'm not replacing a with 45. A is still a, as we can see here. Instead, I'm replacing h of a with 45. This is different. Go back and notice the difference between these two questions so that you don't make that mistake when you're solving. We're going to substitute h of a. Here's h of a. It equals 45. We're going to substitute h of a for h of a. So 45 is going to go in place of h of a. So we're going to put 45 equals a squared minus 5. So to solve this, we should know, we're actually going to do more of this tomorrow, but we should realize that we add 5 to both sides. That cancels this on this side, and over here 45 plus 5 is 50. So we have 50 equals a squared. And the opposite of squaring something is to take the square root. So we're taking the square root of both sides. And a little sidebar over here. When I take something and do square root as an opposite operation, this is when I do square root as an opposite operation, I must recognize that my answer can be positive or negative. So I'm going to do a little sidebar to illustrate that. If I have x squared equals 25, this is one we know, so that's why I'm doing this one. We know that if x squared equals 25, well, x must be 5. But as we saw earlier, if I were to put a negative 5, if I were to substitute a negative 5 in for x, negative 5 squared, negative 5 times negative 5 is also 25. So my answer is not just 5, but it can also be negative 5. So that same idea applies here. Anytime I take the square root in order to cancel a square, which is what it does, this side over here, I've got to remember, can be positive square root of 50 or a negative square root of 50. I write that by doing plus or minus like this. So now I've got to break this down. This is something we did yesterday. Okay, so on this side, square root, cancel square, and all I have left is a. on this side, I have to break down 50. Now that's 25 times 2. 2 being prime, remember. And then 25 breaks down into 5 times 5, which are both prime, which can cancel because we have 2 of them. So 5, let me put my equal to sign on this side, plus or minus, positive or negative, 5 square root of 2. That is what A can be. So it's like the graph, we ended up with 2 answers. And that's not always the case. You don't always end up with 2 answers, but I just wanted to illustrate that. Okay, that concludes today's lesson. This is a little bit less than a normal lesson, and that is because I felt like our first day lesson was a little bit long, only because it really should have included that orientation. So normally your lessons will be anywhere from an hour to an hour and 15 minutes, the same amount of time as a class. All right, thank you, and don't forget to do practice with your MyLabs Plus, and keep up with your guide as to where you should be, what homework you should be doing, what quizzes you should be doing, what projects you should be doing, and when to take your test. So that is substitution with function notation. Now I'm going to introduce you to piecewise functions. A piecewise function is when you have 2 functions and they have certain parameters. We call these parameters the domain. So the domain of the first function, f of x equals 4x minus 2, is x is less than or equal to negative 5. That means that x is only smaller than or equal to negative 5. It could be negative 10, negative 20, and so on and so forth. So I'm looking at my x values. The top function is only when x is less than negative 5. A little typo there, so I fixed it. The bottom function, f of x, still this part goes with both of them, f of x equals 3x plus 1 is when x is greater than negative 5. So notice there's no equal to under that. So it's things that are over here, not including negative 5. So we'll talk about this number line in a later segment. So if we want to find f of 10 using this piecewise function, 2 pieces of a function, then f of 10, we have to first determine, is that less than negative 5 or greater than? Well, obviously it's greater than negative 5. So we're going to use this function. So that equals 3 times 10 plus 1. So I have a lot of students who want to try and plug in 10 into both functions, and they think there's 2 answers. No, you have to look at the domain. Which domain is 10 a part of? It's a part of the domain of the lower function. It's not a part of the top function at all, because the top function stops at negative 5. Okay, so that equals 31. Then these are some common mistakes, so with these numbers I chose 10. I think was obvious. 0, it's very important to recognize 0 is in between positive and negative numbers. So since negative 5 is going towards the positive realm, 0 is greater than negative 5. So again, we're going to plug 0, bottom function, 3x plus 1, now is 3 times 0 plus 1, which is just 1. F of negative 2. Okay, so this has to do with number sense. Do you realize how this number line counts? Here's negative 5, and then as we go this way, we get negative 4. So negative 4 is actually greater than negative 5. Negative 3, negative 2, put those negative signs on there. So negative 2 is greater than negative 5. On this way, we actually, our numbers get larger in absolute value. 6 is larger than 5, but negative 6 is smaller than negative 5, and so on. So we're again going to use the bottom function 3x plus 1. So that's negative 6 plus 1, which is negative 5. So you should try and do these without your calculator and then do it with your calculator just to make, test yourself in your math. It's really important to understand, to kind of be able to estimate the answer, because calculators, well, they don't actually make mistakes. It's you making mistakes as you put things in. F of negative 10, so obviously negative 10 is on this side of negative 5. So that is the first time we're going to use this top function, because that is less, negative 10 is less than negative 5. And so this, remember, is our domain. So we're going to plug negative 10 in for x. So we have 4 times negative 10 minus 2. Negative 40 minus 2, which is negative 42. Alright, now we're going to look at piecewise functions on a graph, and not only piecewise functions, but substitution with function notation. We're going to use a piecewise function, but really it could be any graph. I went ahead and did a piecewise function. This is what piecewise functions look like graph. You see here is one function. That would be a linear equation, a linear function. And the second part is yet another linear. And then to the best of my ability, I drew a quadratic. It's a little off, but we're going to be exploring these a little more later. So you have actually 3 functions. It would be 3 equations that would go with this graph. And so it would be a piecewise function. But really, that's not what we're going to explore. What we're going to look at is this problem here. Now let me go up a little bit more. Okay, so one thing I forgot to do is label this f of x. So usually this is labeled y, but it doesn't have to be labeled y. In this case, we're going to name it f of x, and we're going to name this axis the x-axis. So we have 3 problems we're going to use this graph with. The directions say substitution with graphs and function notation, use the graph to find, and then we have 3 different problems. So f of 12 means we're looking at the x, the input value is always this scale right over here. And we're looking for 12. So we go to our inputs and we input 12, just like we did with the equation. We inputted 12. But in this case, it's a graph, so we go look at 12 and we go up to see, where does 12 hit my graph? Right here. So my input of 12 has an output of 28. So f of 12 equals 28. And then we have another one, f of 21. So we're going to go to 21. Now this one I had to estimate. So I kind of have to look at this. What am I counting by? Well, technically I'm counting by 3. I've just skipped every other one. So we really have 3, 6, 9, 12, 15, 18, and 21. And then we go up at 21, right here. We go over to our output, and it's 34. I'm going to do another one before I go to F, letter F. I want to do one where I actually have to estimate a little bit. So let's do F of 29. So I'm counting by threes, so this one right here that's not labeled is 27. And I know that 29 is between 27 and 30. It's closer to 30. So I'm going to say it's about here. So I have to estimate. I probably, unless I actually knew the equation for this function, I probably am not going to get this exact. It's an estimated answer. Right here is where I'm guessing, I'm estimating that 29 is. So I go over from that point, and now I have to estimate this number. I'm going to say it looks like it's 31. It's between 30 and 32. I mean, I could say it's maybe slightly under 31. It's 30.9 or something. I really think it's basically 31. So that's an estimation, and sometimes you have to do that when you read a graph. Now I've flipped it here, and again, this is find x when f of x equals 26. So I'm trying to find I have the answer here. I have 26 is in that spot. I'm trying to find the x. So I have what's called the output. What I've been calling the output is always my vertical axis. So I go to 26 on my vertical axis, and notice it actually is at 2 spots. So I have 2 answers for x. So when f of x is 26, x is 6, but also, put a comma here, x can be 9. So it's both. Both are the answer. Okay, that concludes this lesson 2. It's a short lesson, so you're going to be expected to move on, but it's also short because the orientation was a bit longer than I expected, so the orientation, lesson 1 and lesson 2 should be done in week 1. So that concludes lesson 2, and do your MyLabs Plus, and don't forget to keep an eye on your schedule, and don't miss any of your quizzes or tests.